function 2. Also a function composition because I have a function inside of another function. So g prime of r. Now I have to have a sum of two different products. I differentiate the first function, 2r, multiply by the second function, plus I copy the first function, but now I have to differentiate the natural log. When I differentiate natural log, I get 1 over whatever is applied, it is applied to, but then I have to multiply by the inner function prime, which is 2. I will just condense it a little bit, we cannot do anything to it. So 2r natural log of 2r plus 1 plus 2r squared divided by 2r plus 1. And this is it. That's final. We learned a lot of rules so far. The square root of x, power rule, quotient rule, product rule, natural log, exponentials, a lot. Here is a question for you. How do I differentiate a function like this? Sine x raised to power tangent x. We have never seen this before. We had all sorts of situations of any type so far. I can't think of anything we haven't seen. But not a function raised to another function. We had a function inside another function. We had functions raised to a power, that it was a number. We had quotients, we had all sorts. But this is the first time we see a function raised to another function. And the question is, how do I do this?
If we bring the tangent function down, multiplying it by the sine function, subtracting 1 from the tangent, getting us cosine squared x and the exponent.
Can you say that again?
We bring down the tangent and multiply that by the sine of x, but in the exponent of like sine x, would it be cosine squared x?
No. No, we cannot do that. Always give it a shot. It's okay. Anyone else? Anyone else has any idea?
You turn it into a logarithmic function.
Very good. So, no rule. By rule, I mean no differentiation rule. No differentiation rule is applicable. Don't try. So we're going to denote this function by y. That's our first step. Y is sine x raised to tangent x. We will apply natural log to both sides. Like we took the square root from both sides, like we differentiated both sides, in the same way we're applying an operator to both sides. Previously we applied the differentiation operator. Now we're applying natural log operator. So the left hand side becomes natural log y, and the right hand side, does anyone remember natural log of a base raised to a power? What happens? The power goes in front as a factor. So this becomes x natural log a. And this is the rule we are going to apply, but this is a log rule. It has nothing to do with differentiation. So when we apply the natural log to this side, we just get that. But when I apply natural log to this side, tangent goes in front, and I multiply by natural log of this base. Do we understand this step? Is this okay so far? Is it a yes?
Yes.
Good. Now, yes, of course. We are going to differentiate implicitly. And then solve for dy over dx. So, natural log y. Remember, y is a function. Natural log of a function prime will be 1 over y multiplied by dy over dx equals. I'm differentiating a product. I have to have a sum of two terms. Tangent prime first is secant squared times natural log of sine x plus. I copy tangent, but now I have to differentiate natural log of a function. So it's 1 over sine x multiplied by the inner function prime, which is cosine x. I want to caution you that this is tangent multiplied by cotangent. So I'm going to calculate on the side. Tangent is sine x over cosine x, because the answer is always 1. And cosine x over sine x, as you see, it's 1. Every time you multiply tangent by cotangent, because it's a multiplicative inverse, you get 1. So then 1 over y dy over dx equals secant squared natural log plus tangent x. See, I wrote it on the side. That's why I talk too much. That's my answer. No excuse. I just calculated it. Okay, finally we have to multiply both sides by y. And I'm not going to multiply by y, I'm going to multiply by the exact function. That is y. So I'm going to write dy over dx equals sine x raised to tangent x, and in brackets I have secant squared x natural log of sine x plus 1. So this procedure is called logarithmic differentiation. Logarithmic differentiation. First we applied log, and then we differentiated implicitly, because now we no longer had the function directly, we had it implicitly.
Wait, why'd you put the sine x and tangent x back in? Didn't see that.
I have to multiply both sides by y. I'm solving for dy over dx, not for 1 over y dy over dx. So when I multiply both sides by y is sine x raised to tangent x.
Okay.
So let me write it here. Multiplied by y, both sides. Any questions? Any questions? Okay, let's look at another. If you'd like to choose, or you can make one up. I'm going to choose one in the meantime, and you will make one up if you want. We have no differentiation rule for this. Our only hope is to apply natural log to both sides. Natural log y equals, cosine goes in front, and I have to apply natural log to this. So natural log, apply to natural log. Do I have to show anything in between here? Is this step clear? Don't be shy. Say if it's not. Any questions here?
No.
Okay, so now I applied natural log to both sides. I'm going to differentiate both sides implicitly. Remember, this is a product, so I have to have a sum of two terms. When I differentiate natural log, I have 1 over y, dy over dx equals. I differentiate the first function, I get negative sine x multiplied by natural log of natural log x. And then plus, I copy cosine x. And when I differentiate natural log, I get 1 over natural log x multiplied by the inner function prime, which is 1 over x. I will rearrange it slightly to condense it a little bit and multiply both sides by y, but I will multiply by the original function, which is natural log x raised to cosine x. So dy over dx equals natural log x raised to cosine x negative sine x times natural log of natural log x, and plus, I'm going to write this as one fraction, cosine x over x natural log x. And surprisingly, I didn't run out of room. It's amazing. Any questions? Okay, finally, I think we should go back to log that does not have base e. Has any base but e. And it's all based on the change of base formula. So let me refresh your memory one more time. So natural log x prime is 1 over x. Natural log of a function prime is 1 over the function times the function prime. But now when we have log base a of x, because we can change the base very easily, let's do that if you'd like. So log base a of x is the same with natural log x over natural log a. So instead of differentiating this, I'm differentiating that. So there is a natural log as a constant in the denominator. That's the only change. So then this becomes 1 over x natural log a, right here. And obviously, if this is a function, I'll multiply by the function prime, and here I have the function. So log base a of f of a function prime is 1 over the function times natural log a times the function prime, because of the change of base. So log base a of x is this. It's a constant. This stays as is. But I have to differentiate natural log, which is 1 over x. And now I would like to practice this when the log has a different base than e. Here's 1. F of x equals log base 5 of x e to the x. So first of all, I need to remember that log the base is 5. So I will have a constant in the denominator of natural log 5. Then I have to notice that this is a product, so function 1, function 2, and see what happens. Okay? So let's differentiate this function. Any questions so far? Anyone? So then f prime equals 1 over x e to the x multiplied by, so it's the function, I copied it, multiplied by natural log 5, multiplied now by the function prime, which is a product. So the first function prime is 1 times e to the x plus the first function times the second function prime, which is e to the x. So this equals, I will factor out e to the x from the top and get x plus 1 in parentheses, or 1 plus x, but I prefer x plus 1, over x e to the x natural log 5. And I can simplify. So the simplified form is x plus 1 over x natural log 5.
Excuse me, Professor. Is
Yes.
that page 11 or
Say it again.
is that page 11 at the top?
Yeah, I'm sorry about that. I need triple size pages. Sorry about that. Any questions? Should we look at one more?
Yes.
Okay, so let's look at y equals log base 2 applied to e to negative x multiplied by cosine pi x. The same question, find the derivative. I noticed that this is not natural log, so I have to have a constant in the denominator of natural log 2. So y prime is 1 over the function multiplied by natural log 2, and now I have to multiply by the inner function prime. It's a product. E to negative x prime is e to negative x times the inner function prime times cosine pi x, don't forget plus. I copy e to negative x, and now this is cosine prime, and it also has a different function inside. So cosine prime, I need parentheses because it's negative sine pi x, and multiplied by the inner function prime, which is pi. And maybe to omit any confusion, I'm going to use brackets here because I don't really like nested parentheses. They're not very friendly. Sometimes it's difficult to see what's happening here. So I'm going to delete that. Okay, so now I realize that both terms are negative, so I'm going to pull out negative e to negative x. Both terms will be positive, and there is nothing else I can do. And I will simplify with e to negative x. So equals, so negative e to negative x. This term was negative, now it's positive. This term was negative, now it's positive, and I'll put pi in front. So plus pi sine pi x. Everything divided by this, e to negative x times cosine pi x times natural log 2. And I can get rid of a little piece. It's still something. So I'm going to write the final answer one more time here. So minus in front of the fraction line, the top cosine pi x plus pi sine pi x, and the denominator cosine pi x times natural log 2. Do we need to look at another logarithmic differentiation?
Just real quick, what made in the bracket negative e to the negative x? Why did that become negative e?
Here, right here?
Yeah.
Okay, perfect. Let's explain that. So e to negative x prime is e to negative x multiplied by negative x prime. But negative x prime is negative 1, which makes the whole thing negative e to negative x.
Okay. Thanks.
Better?